Causes of deterioration. Generally, what are the causes for the failure of a structures? Normally, local settlement, movement of a formwork, vibrations, and internal settlement, setting shrinkage. So these all occurs during the construction stage process, and due to the temperature fluctuation also, and also due to weathering actions. And also due to use of poor quality materials. So when we use not an adequate proper quality materials, it also contribute to the deterioration of our structures. And also the major thing is not using in proper mix designs. So the mix design plays a crucial role, so we have to make the design in a right way. So these are all the general causes of deterioration. So the design and construction flaws. The well-designed and detailed concrete structures will show less deterioration in comparison with poorly designed and detailed concrete. The beam column joints are particularly prone to defective concrete if the detailing and placing of reinforcement is not done properly. And also we need to look after the mixed design. So the mixed design have to make as per the standards and specifications. We need to look after the water cement ratios, the ratio of coarse and fine aggregate, and the size of aggregate we are choosing, and the water content, cement content, and the volume of coarse aggregate and fine aggregate. So if the mixed design is not proper, so the concrete will obviously lead to the reductions in strength. Environmental effect. So the micro cracks present in the concrete are the source of ingress of moisture. So ingress of moisture in sense the moisture enters into the concrete, and also the atmospheric carbon dioxide when it enters into the concrete, which attacks the reinforcement and it reacts with various ingredients of concrete. Temperature fluctuations also will contribute to the deterioration of the structures. So when the structure is under hot weather or when the temperature fluctuates, so it also causes the deterioration of our structures. It also causes the failure of our structures. Quality of material used. The quality of material to be used in construction we have to ensure by conducting various tests as specified by the IS code, and also the alkali aggregate reaction sulfate attack, which also results in early deteriorations. So the concrete in general, it is a function of the concrete strength in general, it is a function of cement, the materials we are using, the cement, fine aggregate, coarse aggregate, and we have to look after the materials, or in we have to look after we are adding the materials in right quantity, and also we have to look after the materials are in good quality. So we have to ensure the quality of the material, as well as we have to ensure we are adding the adequate material to make the concrete. Cracks. So when we say the name cracks, it refers to the fracture. So the cracks we can classify into non-structural cracks and the structural cracks. So the non-structural cracks which does not possess any threats to the building. So we can say hairline cracks are an examples of non-structural cracks. Structural cracks. So the structural cracks which may causes threats to the structures. It may causes a structure to get deteriorate. So we can classify the structural cracks into shrinkage cracks, overloading cracks, settlement cracks, and cracks due to thermal stresses and due to chemical attack and corrosion. Shrinkage cracks. So the shrinkage cracks are the cracks that forms in concrete due to a loss of volume during the curing process. They are the common issues that occurs when water evaporate from the space between the concrete particles, causing the particles to move close together. So the shrinkage cracks are caused by combination of drying and temperature differences. The chemical process that hardens the concrete, which generally produces a heat, causing the concrete to expand. At the same time, the concrete surface loses the water through evaporation. So what are the prevention we can do? So to minimize the shrinkage crack, you can use a fog spray to decrease the evaporation rate from the concrete, or else we can use a wind cutter to reduce the wind speed, which can increase the shrinkage cracks. Overloading cracks. So the overloading cracks are the cracks in concrete that occurs when the weight placed on it is more than the concrete capacity to support. So the overloading cracks can cause a serious damage to the concrete structures, which includes weakening the slab's bending and shear capacity, and also accelerating the steel corrosion, which can reduce the structural durability. Settlement cracks. So the settlement cracks are a small narrow cracks that occurs when a building settles on its foundation. So what are all the causes of settlement cracks? So generally the settlement cracks can be caused by a number of factors, which includes when we look after the soil, inadequate soil preparation, soil erosion may causes the soil to move, which can lead to the cracks. Roots. The decomposed tree roots under the foundation can cause a settlement crack. Weight. Adding an additional weight to the structure can cause a settlement crack. Earthquakes. So the sudden damages from the earthquakes can cause a settlement crack. Chemical attack. So, the chemical attack on concrete can result in potential issues such as cracks in concrete, volume change, and also it leads to structural deterioration. So, this significantly reduces the lifespan of a structures, and in severe cases, it leads to the structural failure. So, the chemical reactions in buildings can cause cracks in structure due to expensive forces. So these reactions can include alkali silica reaction, sulfate attack. When we see an alkali silica reaction, a reaction between silica in aggregates and alkali hydroxide in concrete, so which forms like a gel that expands when it absorbs moisture. So this expansion can causes an internal pressure and cracks. Sulfate attack, a reaction between a sulfate ions and hydrated compounds in cement, which forms an expansive product that can causes a cracking. So the other chemical attacks on concrete include acid, some alkalis, numerous salt solution. So when the structure is near the seashores or offshore structure, so the building is prone to a chloride attack. So numerous salt solution and organics such as fermenting liquid, sugars and animal oils. So to prevent the alkali aggregate reaction, we can carefully select in aggregates and consider a silica content. To add a strength and stability to the cracked concrete, we can install a sheets or strips of a carbon fibers over the cracked area. Thermal stress cracks. The thermal stress cracks or cracks in glass or concrete that occurs when there is a rapid change in temperature. So when we see in concrete, the thermal cracking in concrete can be prevented by monitoring the temperature of a concrete mix and ambient temperature and differential temperatures. So the other ways to prevent thermal crackings generally include using a low heat cement and using aggregate substitutes like fly ash, limestones or slag, using low water to cementitious material, protecting a new concrete from cold weather with external heat. Cracks due to corrosions. So due to corrosions, it may also lead to spalling of concrete cover, cracks parallel to the reinforcement, spalling at edges, swelling of concrete, dislocation and internal cracking and reduction in area of steel reinforcement. So the quality of supervision also plays an important role. So during the construction work, the construction work should be carried out as per the age shown in the specification. So adherence to the specified water cement ratios controls the concrete strength, permeability and durability of a concrete. So the insufficient vibration may result in porous and honeycombed concrete. So whereas the excessive vibrations may also lead to segregation. So we need to make a good quality supervision during a construction process.